I will start introducing myself and also my colleagues that joined the meeting today. I'm Cristina Conejo, part of the i4CAMhub EDH from Spain. With me, I have Cristian Franco and Sergio Izquierdo, part of the development team, and also Sergio Luján, that is a manager at the SME, that beneficiary of the service of i4CAMhub. Christian, if you can skip to the next slide, I will present the agenda for the meeting today, for the time that we have. For today, I would like to have a couple of minutes to present i4CAMhub project and also the context on the renewable energy and solar power markets. As well, my colleagues are going to present our success story, the company and the use case that we have developed. And at the end of the session, we will have time to share and discuss about any question that can rise during the meeting. Starting by the i4CAMhub presentation, I would like to talk about our objective, that is to competitiveness through the digital technology. This is our leitmotif. We are the EDH representing Castilla-La Mancha, that is a region in the center of Spain. The consortium is coordinated by i4CAM, that is a technological center, and also the University of Castilla-La Mancha, and different members that represent different areas in Castilla-La Mancha, such as European Center of SMEs and Innovation, and also the Parque Científico of Castilla-La Mancha. Our technological focus is artificial intelligence, cybersecurity, and quantum computing. And due to the region where we develop our services, our sectorial focus is industry, agro, and energy. Energy is the sector where we have developed this service. Regarding our project funding sources, we would like also to highlight that this project, i4CAMhub, is funded by the European Commission through the digital program and also by national funds. In fact, this the service, this success story that we are present today, is funded by PADI, that is a national instrument that allow us to develop this kind of services for SMEs. If we jump into the context, the global context of the photovoltaic solar sector, please, Christian. I would like to highlight as well that the solar photovoltaic is the fastest growing renewable energy source probably globally. This is because the cost has dropped 90% in the last decade, making it the cheapest source of electricity in any region, probably. If we see from the European point of view, the EU is aiming for more than 600 gigawatts of solar capacity in 5 years, so by the end of the 2030. And there's some plans or programs like the European Green Deal or the Repower EU. If we see from the national point of view, most of you must know Spain is one of the Europe solar leaders due to our high solar irradiation, the supportive regulation as well, and also the significant funds from EU. Some example of that are the PERTE initiative or the Next Gen that came from the last years. Knowing that and moving into numbers, for example, in 2023, Spain have more than 25 gigawatts of capacity, and in the way of having more than 75 gigawatts of capacity by the end of 2030. More or over 200,000 of self-consumption system active by now. So this is a huge number that allow us to develop services that increase and enhance also the management of this kind of project. But how Spain is achieving or is going to achieve this number also in the future? So basically following the Spanish National Strategy and Climate Plan. And also empowering citizens, SMEs, and also local entities to produce and manage renewable energy. Some example of this initiative is the initiative for the services or the service that we have provided thanks to i4CAMhub project to an SME of our region of Castilla-La Mancha. There is GFM, the company that we are going to present later. If we move a little bit into the pros and cons of the development of this kind of energy, I would like also to talk about the main challenges that this kind of companies and also the end user face every day. So some challenges like the regulatory complexity, the financial barriers as well, the social awareness, and also the technical integration of shared energy and storage system are the challenges that every day they have to face. But in the other hand, we have some technological opportunities that the digital platform of communities energy that allows or increase the performance of this kind of the use of this photovoltaic energy. Peer-to-peer and collaborative self-consumption model, distribute energy storage, for example, is another example of how these energy communities can use or introduce technological opportunities into their services, into their products. For us, some development keys that we would like to have in mind is to simplify the regulatory framework is a key enable for this sector. Target financial support to enhance how the funding is distributed, to boost the public participation, and also to promote the collaboration between public and private entities. Knowing these some pros and challenges that the energy communities face in their services, we would like to share with you how i4CAMhub has worked in a service, in a prototype of a digital twin that have in mind the main challenges and allows to develop the opportunities to introduce and enhance the service of management of an energy community. For that, to present this success story, I laid my colleague Sergio Izquierdo to present the company and the use case. So thank you very much, and Sergio, the floor is yours.
Good morning, everyone. I'm Sergio Izquierdo, the technical lead and developer, together with Christian, of the digital twin. Okay, and first I'm going to present the motivation and needs to save the project and walk you through the technical architecture and data workflows that made it possible. Let's take a deeper look. And the customer was dealing with GFM, a Spanish company with over 25 years of experience in the renewable energy sector, as highlighted in the 25th anniversary logo here on the slide. They are a pioneer in renewable energy in Spain, specialized installer of photovoltaic solar panels for residential, commercial, and industrial environments. And most importantly for this project, an innovator and developer of efficient energy solutions, especially within the framework of energy communities. Okay, their mission goes beyond installation. They help communities generate their own energy, optimize its use, and transition toward a smarter, more autonomous energy system. Now talk about the problem. The problem, which is the problem? Customer needs. Understanding the problem, let's now take a closer look at the customer-specific needs, which define the scope and the structure of our digital twin solution. First, manage decentralized energy system involving with multiple stakeholders. One of the most critical challenges was managing a decentralized energy ecosystem. This includes multiple homes generating their own solar power, using energy different, and often being disconnected in terms of data visibility. To address this, the digital twin needed to monitor and optimize performance, manage energy flows between producers and consumers, sometimes in real time, track consumption patterns, and ensure efficient use of energy, balancing supply and demand dynamically. Without a unified system, each stakeholder operates in isolation with limited efficiency and collective optimization. Another important goal was to make energy more visible and understandable to the actual users, the community members. We needed to provide personal dashboard, clear data of energy flows and impact, a sense of ownership over local energy. This is not just a technical challenge, it's also about engagement and trust. Improve transparency in energy distribution. Transparency is essential in shared system, especially when community members need to trust how energy is produced, distributed, and rewarded. The digital twins allow real-time and historical data access, alerts on anomalies like discrepancies in usage, visibility on where and how energy is flowing. With the dashboard, every member can see their role in the ecosystem, and that builds credibility and collaboration. Next, they have enabled users to monitor their own energy. Each user needed to track contributions, how much energy they produce, consumption, real-time and cumulative, surplus, and shortage, so they can adjust behaviors or participate in load balancing. We designed the system so users could answer the simple question: I am producing more than I consume. Okay. Manage electric vehicle charging station. Electric vehicles are becoming more common in the community, and this brought a new energy load challenge, especially during peak hours. We implemented monitoring tools for EV charging points, load curve analysis to detect charging patterns, and integration into the overall community energy view. Also, implement predictive maintenance. i4CAMhub also wanted to move away from reactive maintenance, so we built early detection features based on sensor data, alerts of underperformance or hardware inconsistencies, and a forecasting model that helps plan interventions. For example, if an inverter underperforms for 2 days, the system flags it before it fails completely. And last, promote data traceability. Lastly, the data traceability was essential both for operational clarity and for reporting purposes. We ensured all data points are time-stamped and stored. Every user action and device reading is traceable, and historical data can be of reanalyze as needed. Okay, so as you can see, this wasn't just a matter of displaying solar production. It was about building a smart, responsive ecosystem that brings value to every stakeholder in the community. Now let me walk you through the digital twins architecture, which we developed to solve this challenge. Data collection ecosystem. Here we have the architecture of the digital twin. Okay, we have three primary data streams: A, solar inverters, two MQTT brokers in the left side of the architecture. The inverters convert DC to AC and generate real-time production metrics. These data are published using MQTT, a lightweight messaging protocol ideal for IoT. And this data sent a central and public MQTT broker deployed by inverter company Renewable collect this information for further processing. Okay. In the charging point, if it's charging station to Raspberry Pi through Modbus TCP. The charging station communicates using Modbus TCP, common in industrial environments. A Raspberry Pi acts as a local hub that queries this data and exports it via custom REST API we developed. And in the right side, in the architecture, we have IoT devices, Shelly. Shelly is the company of IoT devices. To Cloud API. This monitor real-time electricity consumption in homes. Data was retrieved via the Shelly Cloud API. Okay. All data is gathering in the same place. Okay. Which tool we use for this data processing layer? Telegraph. Okay. Obviously, all this raw data needs normalization and centralization. We used Telegraph, an open source data collector from the Influx data stack. Subscribe to the MQTT broker for inverter data, queried the Raspberry Pi API, particularly for charging station data, and published consumption metric from the Shelly API. Okay, this modular approach allowed us to scan and add more devices later with a major engineering. This data is necessary storage. Okay, data storage we use is InfluxDB. All time series data flows into InfluxDB, a high performance time series database. Why InfluxDB? Because high ingestion rate is powerful query language, native support for time-based aggregation, average, max, sum by hour day, and lightweight and easy to deploy. Okay. When we have this data, how we see them with visualization through Grafana. We use Grafana to build the dynamic dashboard, overview of total production against consumption, alerts for mismatches, production too low, individual household performance, and EV charging load curves. These dashboards are embedded in a web application use iframes. Okay, providing a clean interface, role-based access, and users and real-time interaction. Users can see how much they produce it, consume it, and whether they're net contributors or consumers. That visibility builds trust and engagement. Okay. At last, what we do with this data? Prediction engine, okay, forecaster. We train a machine learning model with XGBoost, this is a kind of random forest technical to predict next day solar generation using historical production data from InfluxDB, okay, and radiation and weather forecast. The model runs once a day, and the results are written back to the InfluxDB for visualization. This enables proactive energy management, knowing ahead of time is there likely to be a production shortfall or surplus. This is the part that gives meaning to the concept of a digital twin, as it allows us to obtain information that help with the decision making, manual or automatic, that will allow the asset, in this case, the energy community, to improve its performance. Okay. To summarize, we address complex needs using a modular, scalable, and smart architecture. We integrated multiple IoT devices, normalized their data, build forecasting models, and visualize everything in a user-friendly way. The digital twin we developed empowers both administration and individual users to make informed, proactive decision about energy use. Now Christian will show you in detail with the developed application slide. Okay, thank you very much.
Thank you, Sergio. Well, in my speech, I'm gonna show mainly the architecture we saw before by Sergio's explanation, and let's try to understand the container structure. Okay, the container structure has like six containers. We have Telegraph, we have Grafana frontend, the forecaster, this one that is kind of an auxiliary container that is to keep alive the MQTT connection. And then the InfluxDB, that is the database we use. So these are the different functionalities we have in our architecture context. So in my speech and in my presentation, I'm not gonna focus on the backend, mainly because we want to explore the data, you know. So I'm gonna focus mainly on the content of Grafana and frontend, okay, in order to understand the data properly and to know how to exploit the potential of this data. Okay, so also the forecaster is really important to keep it in mind, because well, nowadays there's like a year ago we made this project, so we have historical data from 1 year stored on the InfluxDB. So that's also a good reminder that we could use this amount of data to train different kind of models rather than the XGBoost that is really well performed. So in this sense, I'm gonna go to the interface of our web service. That is, this is the different views we have. We have a map, we have generation view, consumption view, user view, community view, and the warnings, okay, with all the maintainers. So let's move to the map. Just it's a map where we have the locations of all the users, okay. In this one we've got the GVM office, okay, and the installations where we have the charger and some inverters. Now the generation view, that we have a table with the different users, And then we have different metrics. Okay, I'm gonna move to this one, and we are gonna see it bigger. Here we have the PV inverter production, the production, and the model we are deploying for forecasting. Okay, so we have in green the real production, and in orange, kind of orange, the prediction. Okay, also we have the battery state, the battery capacity, and we have the energy we produce from 12 a.m. or p.m. and a.m. and also the power we have right now. Okay, and this has a latency of seconds. Okay, so that's a good point to use Grafana and to remark the Grafana power in this sense, the Grafana potential, because we were studying another kind of tools for doing this purpose, but Grafana was the best for this. Then we've got a visualization of all the power of the emitters. Note that since we are starting at 12 at 0, you know, until 8 we've got no production, so that's why we've got this, and then we are starting to with production. Okay, and yeah, you know, we have here all the inverters, and also we can see the intensity, the tension, and other metrics, important metrics. We can select and filter, and you know, and also choose the user or the installation we want. Let's move to the consume view. Here we've got the different devices here, right here, and we can select them. And there we have the consume along the day. Okay, with different metrics also. Now here we've got the user view. Let's read it from the left to the right. We've got the power inverter, the production. Okay, and then we can see how much are we giving to the common net. That is here. Okay, in this sense will be this amount. Okay, and then we've got our own consume. Okay, what we are using about our production, and then we have the charger. If we are charging the battery, we are gonna see this arrow, and in the other case, the other one. So that's it. Then we've got some metrics. This point is important because when you are doing and developing a project like this as a data scientist or developer, or wherever the technical or technological expertise, maybe you don't have expertise in energy sector, or not too much. You're not an expert about energy sector. So the insights of the data are and the metrics you want, the amounts you want to visualize on your digital twin are really important to be represented and choose by the customer in this case. So in this case, we've got these amounts, and I'm not gonna explain it one by one because it will be kind of boring indeed for you, but this is a really interesting point we have to overview, okay, and to see, because it's really important to notice these kind of things, because these details make the difference between you know, a normal analysis and a good one. So okay, in the community view, we've got also the solar power production. Then also here we can see you know, the charger, if we are using or not the charger on this day, and how much power is consuming in this right now, you know, in this moment, and also the power we are giving to the net or starting to the net, and also on the community. Okay. Also here we've got another different you know, global matrix that are mainly some different energies, like for example auto-consumed energy, because the main point of this data gathering and what you want to see with this data is how much energy are you consuming on your own production, and how much are you requesting to the global net. Okay, so here we've got, you know, like the target energy, the auto-consume energy, your total consume energy, and the total production. Some global amounts that you have to know in order to see how is going your day or in your community. Then we move to the warnings and the alerts. Here we've got some also this was given by the customer, you know, because we have to, okay, when we have to know the needing of knowing, for example, that the tension is higher than 250 volts, okay, or for example that the production is under a level. So in this sense, we have some kind of alerts regarding to the moment that it's produced. And then we've got also the register of the charger, okay, that we can see if, for example, the charging point is not on point, you know. It's like, for example, imagine you go to charge your car and you let the charger off. Then you're gonna see it right here, and then you can go and repair it, or just, you know, that's the main maintenance you can do just with data on real time, because you can do it right at the moment it happens. So that's it about the interface and the web tool we made. Then let's talk about the results and the impact it has to this, also to the company and to us, because now we achieved to have centralized data management, and also we have integrated data capture systems from different devices, from photovoltaic installations, from battery, from other systems, and to the charging points. So in these situations, we have definitely unlocked the data value, and then we can go through the analysis of this data, because we are gathering data from every second of the day of different devices, and lots of devices indeed, if we are scaling this. So this leads to lots of kinds of analysis, and also when you are data scientist or something like that, and you enjoy analyzing time series in this case, you can do a lot of things with this data. So for example, if you think about predictive models, you can think about all these kinds of applications, and well, but we can go crazy, we have to choose, okay, because we can try to train prediction models to every one of these applications, but well, this can be extended and scaled on the future, and also when you have gathered data enough, okay. So because, for example, for doing a predictive maintenance software or model, you need you need to register, and you need to register each of your warnings and of your alerts through the time. So when you've got this, and you have the historical data of these alerts, then is the moment you can train a predictive maintenance model, and you can predict each of the warnings based on the historical data you have. So in this sense, as a concept proof, and also a good quality, and giving quality to this digital twin, we train an energy production forecasting model, and that was a XGBoost. I'm gonna move to the other slide to see it. Okay, here note that we have if we go to this graphic, okay, and we focus on one day, most of the days the prediction is really good, okay, because we are catching the pattern, the stationary pattern of the time series. But if it happens something that we can control, and the production goes lower or even higher, like in these other predictions, we are gonna have some error. But this was thought for a year ago, and we had no historical data rather than the amount of time we were developing. So if you think about right now, you can do a lot of things, because now you have historical data from 1 year, and you have unlocked the power of deep learning, because this is a machine learning, classical machine learning model. So okay, it's gonna, if not overfitted, it's gonna run very well. But right now you have another power another card you can play, you know. So in this sense, that's here I enumerate all the flags we captured, you know, because okay, we've got deploying in real time a machine learning model that is throwing predictions for each second of this time series. Then we've got this all the data centralized on the same database and on the same platform. So we can just we are enhancing decision making through this data, because we are taking objective contested decisions, and also this can be on continuous improvement, because you are gathering data each day, so and each second even. So you can just, if you are thinking, for example, on prediction models, you can do all of this and even more, because this, for example, was thought by me, but I'm as I told you, I'm not an energy sector expert, definitely. So imagine what for example, when Sergio tell us what we can do. Okay, so that's a lot of potential in the same project. Well, yeah, that's the same. Now the lessons learned is just for summary. The hardest part in this kind of projects, and as I told you before, I think is understanding the data properly and to go deeper with the customer. So you have to be in touch with him constantly. And also something we note is that maybe you don't need to use MQTT protocol if you use a socket. And I think Sergio Izquierdo is already and right now researching about that. But well, this is such a dynamic technological sector, is such a dynamical sector, so you have to be constantly learning and constantly putting in deploy what you are learning. So well, thank you very much for the attention and so. And now I give pass to Sergio Luján. And okay, share with us your experience or whatever you want.
Okay, thank you so much to i4CAM and the organization for giving us the opportunity of being here. For us, it's a pleasure explaining this experience. And well, some months ago, David and Sergio Izquierdo from i4CAM called me in order to invite us to participate in a pilot for developing a platform, a digital platform for managing citizen energy communities. Well, that's one of our activities. So we agreed that it was a great opportunity, and we started to work together. The experience has been very good. I think the project has given us a lot of a great improvement about all the management we could have regarding to the citizen energy communities, because when you develop a energy community, you try to use several devices, PV inverters, battery inverters, electrical vehicle recharging points. You can use heat pumps. Okay, you can manage and you can use a lot of devices, and not always all the devices are from the same brand. So what happens that if you don't have a centralized platform to monitoring the system, to analyze which is the behavior of the energy community, how are the energy exchange between the stakeholders, is very difficult to set new strategies, to teach the people how they can take advantage of the energy they have, how they can share the energy. So, and what is the most important thing is that people don't see how the energy community is working. They don't know if everything is working well or not, which they cannot measure the benefits. So if you don't have a system like this, it's very complicated to go ahead with these kind of solutions like energy communities. So we started to implement all the communication data with the general device which take all the information, and we went step by step trying to implement all the monitoring system first and the management system then. And in addition to it, we have a huge relationship with i4CAMhub. We have worked together for a lot of time, and it has been a very useful, a very important point in order to work very coordinated. The results have been very good. We have now we have a tool for going to the market with the energy communities. We can teach the people how it works. We can show the people. We can show people how the energy community works, how they can be possible, how we can exchange the energy package, and now for our commercial team it's easier to arrive to the client's requirements. The results, as I have said, have been very good, and for this reason we want to go ahead with a solution, with an improvement of this solution. So we have just presented an evolution of this to another project, which will allow us to make automatic energy exchanges, based on artificial intelligence and quantum computing. So I think that that's the most important impact and that's the most important result. I think that for us as developers of energy communities, we have found a new tool which is very useful. Really, you can believe me, it's very useful. I think that in addition to it, the i4CAMhub step have done a very good work. They have been very close to us during all the project. So that is very important because we have felt very comfortable and we are so happy that we have decided to go ahead with i4CAMhub with a new evolution of this product. So I don't know what else I can say. So let me say congratulations and thank you to i4CAMhub for all the work. And if anyone wants to see the pilot, and if anyone wants additional information, I'm pleased to talk with her or with him in order to show the details of the solution. But both Christian and Sergio have explained it a few minutes ago very well. So that's all from my side.
Thank you very much, Sergio. Thank you very much, Cristiana and Sergio, as well. We have a few minutes till the end, so I don't know if anyone have any question. I give you the time for sharing your thoughts or sharing any doubt about the pilot. Any case, I leave you as well the details of myself, of the project, and I leave you the door open for sharing additional information, for have any further meeting to show the detail of the project, the pilot, the digital twin as well, or any technical detail. So thank you very much to all of you for your time, and that's all.
Okay, thank you, Cristina, for your words.
Thank you.
Thank you to everyone.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you.
Ciao. Thank you. I
Ciao.
close.
Campaña financiada por la Unión Europea Next Generation EU, Plan de Recuperación. Ministerio de Industria y Turismo, Gobierno de España.